hard part is downloading it in the right columns and stuff. But it explains it pretty good last lesson on how, and even this lesson on how you have to separate it between rows and columns on one column. Did you read that or see that?
Oh, yeah. Yeah, I did.
And then you have to put the numbers on one and then the count on one. It can't be like in Excel. So.
Yeah.
So I guess if we know that if we have to make a chart or something, that's the way you'd have to do it. So.
Yeah.
I mean, maybe there's a way to do it on Excel to make pie charts, but I don't know.
There is. There actually is a way, but we weren't ever really trained in it because we did the SPSS part.
Right. So anyway, that's my thought on it. So.
Okay. So we'll start on part 2.
Okay.
Says, ambitious intro to stats students wanted to conduct a survey among church members and ask them about their party affiliation and whether or not they're in favor of Proposition 8. They would like to see if there is an association between party affiliation and voting preference for Prop 8. With a level of significance of 0.05, they conduct a random sample, and here is the summary data. State the null and alternative hypothesis.
So those are that the first one is that they're independent, and the second one is that they're not independent. So.
Yeah.
So you have to say their party affiliation and their preference or whatever is their views are independent as the null, and then are not independent as the alternative, right?
Right. That'll be every single time for these ones.
Right.
Okay. What are the requirements for this test? Oh, that's that. Was it the rows or the cells have to be greater than 5?
Expected counts. So I think all of them.
Yeah. Oh, yeah, that's right.
And so you can get that number on your Excel. So once you put in the numbers, then all that stuff comes up again.
Oh, really? I see.
So you just go on into your Excel and put this top square and put in 250 and 50 on the first column and 120 and 80 on the second column.
250.
And then 50. And then the second column, 120 and 80.
And then I have to clear these other ones, 0.
Yeah, clear all the other ones. Just have those 4.
Okay, how do you clear it all out?
I just clicked on it and then just kind of dragged it and then clear. Or you can just go on it,
click them all.
And click them and clear them, delete them, or. So as soon as you have those 250, 50, 120, and 20, and then the box right down from that, there's a count and then expected. And so the expected row is the numbers for row 1, and then on row 2, the expected row is the numbers. So 222 and 148 for row 1, and 78 and 52 for row 2. So those are all bigger than 5. So.
Count as 220. Yep.
And I think that's what it says on the answer sheet.
So yeah, there are the requirements. Right? It says they're all bigger than 5. Okay.
And then C is what are they, and you have to write those numbers down.
Right.
So 222 and 148 and 78 and 52, and that's what it says on the answer sheet. So.
Okay, I think I'm doing this wrong.
Are you in chi-squared test?
Yeah. So I put 250. You put 250 in column 1.
Yeah.
And 120 in column 2.
Right. And then did you put stuff in row 2?
Yeah, 50 for column 1, row 2, right?
And then 80.
Yeah.
Yeah.
And then you go down to the next box to find the expected.
Okay, I see. All right, I did do it right. All right, I was just looking in the wrong place. Okay, sorry.
Okay, so do you calculate the x squared, or the chi-squared statistic?
So that's on the box over directly across from the one we inputted. where
Yeah,
it says test statistic. It's 33.96.
Yep. Okay.
And then the degrees of freedom is right next to
1.
that. And that's an easy one to figure out. You just, did you
1
see
minus
how
your
you're supposed to do
rows.
that? Yeah.
Yeah.
Times the number of columns minus 1. And that's
Yeah.
And then the p-value, do you guys know how to make that p-value bigger?
Yes.
You click on the p-value cell, and then you go up to that little thing that you showed me earlier, Colin.
Yeah.
Decimal thing, and you just keep clicking on it, and it makes it as big as you want it.
It's in the number category. Do you see it, Mackenzie?
Yeah.
And
Okay.
it has the 0.00, and it has an arrow one way or another, and it can make the p-value as big as you want.
Yep.
So that's how you change that. Because on the answer sheet, it doesn't just say 000, it says the
Oh, yeah.
the 0.000056. So anyway,
Okay. So do we reject the null or fail to reject?
reject it because it's so little.
Yep. State your conclusion based on your p-value and based on the level of significance. So we would have sufficient evidence to show, what was the research question?
That
That they
the
were not
party
independent.
affiliations and the voters' views are
Not
not
independent.
independent.
Okay. Sounds good. Open up the group quiz. Okay, so it looks like we've got a table we've got to put in.
Okay.
Okay, I got mine in.
Oh, you're fast. It took me forever to get them side by side.
You just enter it as it's shown on the quiz, right?
Right.
So like column 4 is
Well, actually, do we put the total in?
yeah.
No, it totals it. Oh yeah, so we don't put that 450.
Yeah, I don't think we put that.
Yeah, that's right. Okay. 50-50. The last one is, oh, so we don't put any of the totals. So just those three. 250, 200, 300, 150, 50, and 50, right?
I think so.
Let's see.
Because the totals are on
Because
there.
the totals are on either side. Okay, good.
Yeah. Which set of hypotheses is appropriate for addressing the research question? Okay, it says, do men voting preferences differ significantly from women's voting preferences? Gender and voting preferences are independent and they're not independent. Top one?
Are independent, not independent, not independent, are independent. Yeah.
The only one, the top one's the only one that says that they're independent in the null.
Yep, so that's it.
Okay. What is the equation for computing the degrees of freedom?
The bottom one, right?
Yep, that's the bottom one.
Yeah. The rows minus.
And,
Okay, what is the correct choice for the degrees of freedom of this problem?
You get 4.
Okay, it says 2 on the spreadsheet.
Oh, I have 3 on my spreadsheet.
I have 4.
Oh,
Yours says 4?
Yeah.
okay, so let's make sure. Column 1 we put 250 and 200.
Yeah.
Column 2 we put 300 and 150.
Right.
Oh, I put. Okay, I did 450 like for row 3. Yeah.
And column 3 we put 50 and 50. Is that right?
Yeah.
And what, you got 3 for degrees of freedom?
Yeah.
Okay,
Okay,
how's
so
that?
I have 2 now.
250 and 200, 300 and 150 and 50 and 50. Is that really what you have?
Yeah, 250, 200, 300, 150, 50, 50, 600, 4. Oh, I put 600, 400 because that's the total on that side. That's where I'm messing it up.
Okay, so 2 is the right answer, right?
Yes.
Okay.
2. Yeah, I put the total on the other side.
Okay.
2.
Okay.
Are the requirements met?
So we go look on our thing, and expected,
Yes.
84, 31. Yes, they are.
What is the value of x squared test statistic for this problem?
Okay, so back on 6, it's yes, there's at least 5 expected counts, so that's the D one, right?
Oh.
I put A. Okay, so there's 5 observed. Oh, yeah, in all cells. Yeah, it's D.
So it's D. I did that too, and then I looked at the bottom,
Yeah.
and I'm like, no, that's wrong. So it's D.
Yeah, it's D.
Okay.
Now we want the test statistic, which is 16.2.
Okay, no. I have 24.30.
Oh, really?
I have 16.2.
Okay, so why?
Let's find out.
Oh, I have 16.2. You know why? Because when I made the p-value really big, it changed it for some reason.
Oh,
That's
right.
weird.
My p-value is really big and it didn't change.
Yeah.
Because I put my p-value back down to 0 and it's 16.2 now. That's weird.
It must have just updated.
Okay, so 16.2 is right.
Yeah, 16.203 is what I got actually. 204. Oh, it's 2 decimals. They only want 2 decimals. So 16.20 then.
Okay.
Round to 2 decimals. Yeah.
Okay.
What is the value of the p-value for this problem?
So there's 3 decimals, so we can change that if we have to on the
It's 0.000.
even when we change it. That's
Yeah.
right, because it's like a lot of zeros out.
Yeah.
Okay.
Which of the following statements best describes the outcome of this study? There is sufficient evidence to suggest that voter and gender voting preferences are not independent.
Isn't that the right answer?
Yeah, A, I think.
There's sufficient that voting are not. There's not, there's sufficient against, there's sufficient. Yep, that's right.
Okay. Now we've got to do it again.
Okay.
Two, 4.
Thank you. Okay, so we're gonna have 5 columns and 3 rows, right?
Mm-hmm. Okay. I think I got mine up too.
142, 170. I can't make my thing big enough to do both at the time. Let's see, 5. 142.
And then open that link.
70 and 170. Okay.
And they want us to do this one in SPSS, it looks like, but they gave us the table, so I think it's fine. Okay. Do people in Europe, Australia, and the United States seek chiropractic care for the same reasons? So 1 is they're dependent, 2 is they're not dependent. What are the conditions for the test met? Yes.
Expected. Yes, they are.
Okay, what is the correct degrees of freedom? Looks like I have 8.
I have 8.
Okay. I opened, or like I clicked on the SPSS or whatever thing, and now my computer's frozen.
Oh.
And I can't click on anything. Good. Okay. Okay. You guys can keep going.
Okay, what is the value of the test statistic?
Okay.
I have 89.76.
That's what your test statistic is?
Yeah.
Okay, I have 7.435.
I have 7.436, but still.
Okay, how am I doing? Why is that happening to me then? I wonder. Oh, I have 7.05 now.
Yeah.
Why does it do that? I have to go click on the p-value and then it updates it. But I guess that's...
Wait, you have 7.05?
Yeah.
What the heck?
Okay, did I do the columns right? 62, 84, 85, 61, 70, 97, 72, 75, 85, 64,
72, 75, 85?
Yeah. 64, 80,
It's 82. 72, 75, 82.
Yeah.
82. Okay. And then 64, 82, 111, 142, 170, 178.
Yeah, that's right.
Okay. Now my test statistic says 7.44.
Yeah, that's right.
Okay.
7.44.
Value.
Okay, p-value, yeah. It looks like it's 0.490. Is that what you guys got?
Okay, let me look at mine. Yeah, let me look at mine really quick. Not having... Okay, 0.490.
Yeah. Okay, so which of the following statements best describes the outcome? We would say that there is insufficient evidence that motivation is not independent.
Yeah. So the third one.
Yeah.
Third, insufficient, not independent.
Right.
And then for number 10, you guys said true, right?
Yeah, true.
True.
Okay.
Okay, let's go over the answers really quick. So 1, 2. So 3 is A. 4 is C.
Yeah.
5 is 2.
Yep.
6 is D.
Yeah.
7 is 16.20.
Yeah.
8 is 0.000.
Yeah.
9 is A.
Yeah.
10 is true. 11 is 8. 12 is 7.44.
Yep.
13 is 0.490.
Yep.
14 is C.
Yeah.
Okay, we good?
Yeah, I submitted. We got 100.
Sweet.
Nice. So I guess we just have to decide if we need to know how to do the SPSS, and if we do, just maybe go over it to make sure that if we do have to, that we'll know how to do it.
Well, I mean, you can even like peek ahead to like, say, when's our next test? Oh, our next test is next week.
Is it?
Yeah. Oh, it opens in 2 days. It looks like.
Our test does?
No, just being able to view it.
Oh, okay. So see if we need to have that.
Right, because they'll tell you before you open the test, open this SPSS file.
Oh, yeah.
Right, and then we'll have to know. Well,
Yeah,
and it's not that hard to do. You just have to like review how to do it so you don't get freaked out during the test.
Yeah.
Well,
So it
if
looks
you have
like.
to open it, wouldn't the data already be in there?
Yeah, the data would be there. You would just have to know how to
Find it.
find it, because that's the only thing that's going to be different is if they don't give us a table to put into Excel, then you're going to have to do it in SPSS.
Yeah.
Yeah. So it might. Yeah. As soon as we figure out if we have to do that, well, I mean, we might need to make sure.
Yeah. And the SPSS files might actually be similar to what the Excel ones are, so you might be able to just put the
Look at
data
it
in there. Yeah.
and look at it. Well, and the data might already be in there, and you just have to figure out where to.
Yeah. Yep. So sounds good.
I know that when I did the individual prep, then there's a thing at the bottom that said video tutorials, and there was like the tutor that came on and showed you how to do everything.
Yeah.
And then he started to show you how to do the one in SPSS, and I didn't click on it. So I wonder if we could just click on that, and it would show us exactly how to do it.
There's a link at the top of the thing that says Video 3 will tutorial SPSS.
Where's that at?
In the book.
Oh, okay. So that way, at least if we do that, we won't be lost if that happens.
Yeah.
Okay. Sounds good.
Okay.
Have you heard back on getting the data for our...
He emailed us. He emailed us this morning.
Oh, he did? I didn't see.
Yeah.
What did he say?
He said, I think there are some corrections we need to make, and then he said when we resubmit it, email him the resubmission, basically.
Oh, okay. Okay, yeah. I've attached your design the study, and my comments are in bold. Okay, that'd be good. Let's see what he says. He said, this is good, this is pretty good too, but I want you to think about your response variable. It is categorical or connotative. If it's categorical, the magic 30 number doesn't really apply. I actually was thinking about this the other night because I was like, oh yeah, our study's categorical, so 30 is not going to really help us. We've got to make sure that we're meeting the requirements of the test. But I don't know how. I don't know because if you think about it, when you meet the requirements of the test, you take X, which is the amount of houses that have lights, divided by the total amount of houses. And then you subtract that by 1 or you times it by whatever your N is.
Right. So we just have to put that in there, right?
Yeah.
Okay. Because the requirements are different for categorical than they are for...
Yeah, so that's the only thing that he said. And he also said, how will you decide if the house has Christmas lights or not? Will you go through at night? What if someone like me has lights up before Christmas but doesn't get finished until early December? Is that the guy in the lights pile or the no lights pile? And he said, not approved yet, but you're very close. I like your creativity. You didn't answer the question I asked about what is your experimental unit, what is your response variable, and is it... Oh, where's that at, I wonder?
Yeah.
It doesn't really say that in there. That question wasn't in there.
Okay.
But we can answer those questions. Which statistical tests will be using for your analysis? When you're ready to resubmit your design, please send it to me through email and don't delete my red comments. That way I'll be able to remember what I said the first time. I'm not worried about the neatness of the completed assignment. I want to make sure you get it right. Okay.
So what's the experimental unit? What does that mean?
I don't know.
Response variable is quantitative. I mean, it's categorical.
Yeah, categorical. It says the experimental unit is the physical entity which you can be assigned at random to treatment. Commonly, it is the unit for statistical. However, any two experiments may be capable of receiving different treatments. I think what he's saying in this case is that who has lights and who doesn't have lights. Like, what are you going to define that as?
So if they have lights, regardless if they're turned on or not, if they have lights on their eaves at all, or on their trees, or...
I would say we'll just go around at night and say whoever has lights on before Christmas. We can change that.
Okay, lights on.
Yeah. Before Thanksgiving, I mean. And then what is your response variable? And it is categorical, so we will be using the 2-portion categorical test.
Mm-hmm.
That should work. When you are ready to resubmit your design. Okay, the only thing I don't know is how many do we need? Yeah. Well, how many do we need of data to
So that n thing,
yeah, so we've got to think about
n times
right, it's n times p hat because we're doing a two-portion test. So it will be n times p hat and then 1 minus p hat times n. And they both have to be greater than 10.
Mm-hmm.
So
n times p hat greater than 10, and n 1 minus p hat greater than 10. So our p hat's going to be the x divided by the n.
yes. So that's where it's like tricky with a categorical test because depending on what your results are, like if say that there's a ton of lights, then your p hat could be like out of 40 houses, 30 of them had lights, say.
Yeah.
And so you divide that number and you get like 75%, and you times 75% times your 40, and you're like you're gonna be able to get over 10 on one, but the other one you're not, if that makes sense. So you've really gotta I don't know.
Well, okay, now remember when you don't know what n is, and so you solve for it to figure out how many n you need?
Yeah.
So you do that by knowing what? You know what I'm saying? Trying to figure out how many you need to make it work.
Let's see.
So we just changed that equation to.
What is that equation?
Well, it's just the same. It's n p hat is greater than or less than 10, and then if we need to solve for n, we just have to put n. We just have to move the p hat to. So we still need to know what the p hat is, though, right?
Right. So the p hat
is going to be x divided by n. So how do we figure out how much do we need?
So do you think we would just have to like make a really huge like population?
Well, it's gonna be like honestly because I don't know like it's gonna be just dependent upon how many lights there are and how many houses we take.
Can we just stick an n in there and see if it works? Like stick 100 as an n in there?
Well, we could, but that doesn't change the fact that we don't know what p hat is. Because even if n is 100, we still don't know what. I'm trying to think. Maybe if we did, you could determine that. You could determine what you would need for p hat to the least amount. Maybe that's what he's looking for. You know what I mean?
Yeah. So if you put 100 in the n and then you have to try to solve for p hat, then
you know that the least amount of that p hat can be is this amount.
Right. Yeah. And maybe is that maybe what he's looking for?
Yeah, that probably is what he's looking for.
So what would that be? So if you solve for p hat and we know 100 is the n, then we times 10 by, no, that doesn't make sense.
So now you divide 10 by 100, which would mean p hat would have to be 0.1.
10%.
Yeah.
Does that, are we making any sense here? Is that a possibility of how to do it? Just because before you have the data, you have to like estimate how many.
Yeah, you just have to guess. Right. Yeah. So, yeah, I'll put that in. But you know it's kind of dumb.
Is that the right way to do it? I'm just trying to think, is that the right way to do it?
I think so. That's the only way I can think of it.
Yeah.
But he said also, he said how you detect, he said will you go through at night? But we even said in there, we will systematically go through streets at nighttime and count how many houses have Christmas lights.
Yeah, so just say yes, we'll go through at night. Because we're going to change the experiment to who has their lights on, specifically. Not if they're up, but if they're turned on. Okay. Is that all?
The thing that frustrates me is like, there's no question in there that says, what is your experimental unit? What is your response variable? Like, never said that up there.
Did he, like, put another thing up that you just didn't see?
He must have.
Yeah. I'm going to look at that end thing and make sure I can think of a different way. But otherwise, let's just see what he thinks about that.
Yeah, I'll get it. I'll submit it to him again this morning.
Okay. Thanks.
Okay. Yep. See ya.
Bye.